This video is about proving lines parallel, part 2, and it's also found in your text in section 3-3. At the end of the last video, we had two ways to prove lines parallel. One of those ways came from a postulate. We started out with the corresponding angles postulate that told us parallel lines implies that corresponding angles are congruent. And then we were told in the last video that this postulate runs both ways, that if corresponding angles are congruent, that implies that the lines are parallel. Using this postulate, in the last video, we proved the alternate interior angles theorem is also biconditional. In other words, not only do parallel lines have congruent alternate interior angles, but if alternate interior angles are congruent, we can conclude that the lines are parallel. Now, from class, we also have a third way to show that lines are parallel, because we showed that the same side interior angles theorem is also biconditional, so that if same side interior angles are supplementary, we now can conclude that the lines are parallel, because this statement runs both ways also. So given these three biconditionals, we can now show whether lines are parallel or not in several different ways. Let's do an example. If we're given that angle 2 is congruent to angle 9, are there any segments that must be parallel based on this information? Let's first identify a transversal that connects angle 2 and angle 9. The transversal has to be touching both angles, and it has to form a side of each of the angles. And this line, line FB, does all of those things. So that is a transversal connecting the angles. Now, what lines form the other side of these angles? The other side of angle 2 is formed by line AB. The other side of angle 9 is formed by line FC. So now that we have drawn this setup, we can see that angle 2 and angle 9 are alternate interior angles for line AB, line FC, and transversal FB. Because we're told that these alternate interior angles are congruent, yes, we can conclude that line AB is parallel to line FC. You try this one. If angle 5 is congruent to angle 9, are there any segments or lines that must be parallel? Let's try another example from this same diagram. Suppose we're given that angle 2 is congruent to angle 5. Are there any segments that must be parallel? Well, our first step is going to be to try to identify a transversal that's connecting angles 2 and 5. So, this line here doesn't seem to be heading towards angle 5. This line here, it forms a side of angle 5, but doesn't seem to be heading towards angle 2. The only line that might be connecting the two angles is line BD here. But is this line a transversal? In order to be a transversal, this line would not have to only touch the two angles at their vertices, but it would actually have to form a side of each of the angles. But line BD doesn't form either of the sides of this angle. It doesn't form either side of angle 5 either. So BD actually isn't a transversal, and in fact this diagram doesn't have any transversal connecting angles 2 and 5. So we can't conclude anything given this information. Are there any segments that must be parallel? No, not from the information we've been given. You try another example. If angle 10 is congruent to angle 11, are there any segments that must be parallel? Okay, let's try another example. This time we're going to have some numbers and some variables and a little bit more complicated diagram. We're told that x is 35. So I'm going to go ahead and label that right now on my diagram. X is 35 degrees. We're told that y equals 15. Okay, so this angle is 2y. So that's going to be 2 times 15. So this angle here is 30 degrees. We have 105 here, and then we have 3x here. So 3 times the value of x, which is 35, is 105. So this angle has a value of a measure of 105 degrees. All right. Looking over this information, I noticed something right away. 105 and 105 are congruent, are equal measures. So this angle here, angle ACE, is congruent to angle CED. Are these two angles anything in relationship to two lines in a transversal? Well, let's see if there's a transversal first of all. This line CE does connect the two angles. So this could be a transversal. Which parallel lines are forming the other side of these two angles? So the other side of angle CED is formed by line ED, or it could be ray ED, depending on how we choose to draw it. The other side of angle ACE is formed by this line, line AC. So we do have two lines, and we do have a transversal that has a relationship to both of these angles. And now that we've extended these lines, we can see that these two angles are alternate interior angles. And furthermore, we've found that both of them have a measure of 105 degrees. So that allows us to conclude that line AC is in fact parallel to line ED. We've shown that using the alternate interior angles theorem, which runs both ways. The angles allow us to conclude that the lines are parallel. Let's keep going on this problem for a little bit longer because I see two other lines that look like they might be parallel. And I want to see if we can prove those lines parallel as well. I don't see these lines crossing in the diagram, so there's a possibility they could be parallel. Let's mark our angles again. We said that x was 35 degrees, and we said that this angle 2y was 30 degrees, and the angle 3x was 105 degrees. Okay, if we're looking at these two parallel lines to see whether, two lines to see whether they are parallel, let's look at the transversals that cut across these lines. We have this transversal, DE, that cuts both lines. And we have this transversal, line BA, that also cuts across both of these lines. So let's see whether either of these transversals has an angle that is touching the transversal and both of each of the parallel lines. Okay, here we have angle X, or 35 degrees, formed between line BD and transversal BA. Let's follow transversal BA over to this other line, line CE. And here's where it touches. So transversal BA cuts this line here, and the other side, the other line in question is forming the other side of this big angle here. So the measure of this bigger angle must be 105 plus 30 degrees by the angle addition postulate. So we have the measure of that is 135 degrees. I'm going to mark that with 2 slashes, and I'm going to write 135 degrees. That big angle. All right. Now that we've extended these lines and marked in these angles, I can see that we have same side interior angles here. So we have to tell whether they're supplementary or not, find out whether they're supplementary to tell whether line CE is parallel to line DB. So let's add up their measures. 135 degrees is the measure of one of the same side interior angles. And 35 degrees is the measure of the other same side interior angle. And those two numbers add up to 170 degrees. Okay, our theorem about same side interior angles says that if they're supplementary, we can conclude that the lines are parallel. But 170 degrees didn't quite make the grade, because in order to be supplementary, these two angles would have to add up to 180 degrees. So there's nothing we can conclude about line DB and line CE from this information. In fact, we can conclude that they're not parallel. So that was a no-go. But on the previous page in this video, we did show that line AC was parallel to line ED. And that was as far as we could go. We could not prove that line CE was parallel to line DB. You try one. If x is 90 and y is 120, are there any lines in this diagram that must be parallel? For further practice with this, see page 87, number 17, and the next page, page 88, number 3, 7, and 9 to 15 odd.